Hello everyone. So this video is going to be about solving problems with hypothesis testing. So this is going to be, I think it's 5 problems that we're just gonna go through, and so you can see what it is that you need to do or what it's like to actually do a hypothesis test. All right. So we'll start with the first one, and and by the way, we are going to do some directional and non-directional tests, so you can see the difference between the two, and you'll see how to actually write a conclusion that's an APA style. All right, so here we go. So number 1, scores on the GRE quantitative section, the section on math, range from 200 to 800. According to the Educational Testing Service, the mean score for people who take the GRE but do not participate in a training course is population mean mu equal to 555 with a population standard deviation of sigma equal to 139. A training program claims that their graduates score higher on average than the population of graduates who do not participate in a training course. As a budding statistician, you have been hired to test this claim. You randomly select a sample of GRE quantitative scores for a sample size n equal to 36 graduates of the program. You get an average score of sample mean m equal to 580 on the exam. Do the graduates who take the training program score higher than the population of graduates who do not participate in a training course? Conduct the appropriate hypothesis test using alpha equal to 0.05 and state your conclusions in terms of this problem. Make sure to use APA-style conclusions. So again, I've highlighted the important information that we need to take out of this particular problem. So the first thing we need to do, remember, step 1 is to state our hypotheses, right? So let's go ahead and do that. So let me go ahead and move this up so that you can see. All right, so hypotheses are stated both in symbols and in words. Okay, let me go ahead and close that parentheses. All right, so in symbols, we're looking for what we're testing here is that our graduates scored higher. So usually I start with the alternative hypothesis because it's easier because it's in the question. So our alternative hypothesis is that mu is greater than 555. Remember, mu is equal to 555. And that helps us with the null hypothesis because it's everything else, right? So the null hypothesis, or H0, is mu less than or equal to 555. So this is what it would look like in symbols. In words, the null hypothesis is graduates who take the training course do not score higher on the GRE quantitative exam. And the research, or the alternative hypothesis, graduates who take the training course score higher on the GRE quantitative exam. Okay, so we've got step 1 done. Step 2 is setting the criteria. That's already done for you. Alpha is equal to 0.05. So the next step is to calculate the test statistic. In this case, because we are dealing with, let me move this up. We are dealing with population parameters mu and sigma. We are using the z-test statistic. Okay, so I like to start with finding standard error first because I don't like having the fraction in a fraction within a fraction. So I like to have just a whole number or a number that I can deal with when I'm calculating my z. So standard error is sigma divided by the square root of n. Sigma is 139, n is 36, so we take the square root of 36, we get 139 divided by 6, which gives us a standard error, or sigma m, of 23.1667. Notice I round up with the fourth decimal place. So now I plug in my numbers for z. I can go ahead and calculate my z. So z is equal to sample mean minus mu divided by standard error because we're dealing with samples, okay? So it's 580 minus 555 divided by 23.1167. That's 25 divided by 23.1667, which gives us a z-score of 1.079, which is approximately 1.08. Now, I look up the probability for this in the z table. So here's our standard normal table from Top Hat. All right, so I pulled it up so that we can take a look at it. And so I am looking for a z of 1.08. So 8, this is the column we're going to need to look down, and then we need to look for 1.01. There it is, 1.0. So our probability, and remember this is to the left, right? This is going to be to the left of that z-score, right? So 0.8599, we're looking for greater than, so that means that we're going to have to subtract 1 from 0.8599, and that's going to give us 0.1401. And here we're back over to the Word document where P is equal to 0.1401, which is 1 minus 0.8599, which I got from the standard normal table. Now, 0.1401, this probability is greater than alpha equal to 0.05. So we failed to reject the null hypothesis. And because we failed to reject, we do not need to calculate the effect size because there is no effect or no difference. So here's our conclusion, our nice APA style conclusion. So we start out with fail to reject the null, and the reason why I have you write this is because I want to make sure that you understand whether we're failing to reject or whether we're rejecting the null. But in true conclusions, you will never see these words, okay? But for the purposes of this class and when you're writing up your conclusions as answers, you need to make sure that you include fail to reject the null or reject the null, okay? So typically we'll start with there is not sufficient evidence to conclude that the graduates who take the training program score significantly higher on the GRE quantitative exam, comma. Now here is where you have to provide the statistics to back up that claim you just made that there is not sufficient evidence, right? So here are the statistics. So we ran a Z statistic, so we put in Z. Our N was equal to 36. Notice that it's in parentheses, equal to 1.08, comma, P equal to 0.1401, period. Okay? So we always write the conclusions like this. And then we typically write another sentence that basically says what we just said in English. Individuals who take the training course do not score higher on the GRE quantitative exam than individuals who do take the course. So there we go. We finished our first hypothesis test. All right, so now let's take a look at number 2. Suppose we want to show that only children have an average higher cholesterol level than the national average. It is known that the population mean cholesterol level for all children is mu equal to 190, with a population standard deviation of sigma equal to 15. We get a sample of n equal to 25 children and find that the sample mean m is equal to 198. Do we have evidence that only children have an average higher cholesterol level than the national average? Conduct the appropriate hypothesis test using alpha equal to 0.01 and state your conclusion in terms of this problem. Make sure to use APA-style conclusions. All right, so I highlighted the important stuff. Again, highlight the important information that we need to pull out of the problem, okay? Step 1, we have to state our hypotheses. So let's go ahead and take a look at those. So here we go. All right. So I like to start with the alternative hypothesis first because it's stated in the problem what it is that we're looking for, right? So in this case, we're looking for higher cholesterol levels, so our alternative is going to be mu greater than 190, right? And so our hypothesis is everything else. Mu is less than or equal to 190. So that's in symbols, right? The null hypothesis in words is only children do not have higher cholesterol levels on average than the general population of children. Our research or alternative hypothesis is only children have higher cholesterol levels on average than the general population of children. So far so good, hopefully. All right, so now we're ready to solve some problems, solve it, right? So remember that the step 2 is selecting the criteria. The criteria was given. It's alpha equal to 0.01, okay? So again, I always start out with standard error. Remember, we're dealing with a sample n equal to 25, so we need to calculate standard error so that we don't have a fraction in the denominator of the z statistic, right? So standard error is sigma m equal to sigma divided by the square root of n, which is equal to 15 divided by the square root of 25, which is equal to 15 divided by 5, which is equal to a nice whole number 3. Z is equal to, so we're going to do the z statistic, right? This is our hypothesis test. We're going to take our sample mean, subtract population mean divided by standard error. So it's going to be 198 minus 190 divided by 3, which is equal to 8 divided by 3, which is equal to 2.667, which is approximately 2.67. And then we look up the probability once again. We look up the probability for 2.67. Let me pull up the standard. The standard normal table. So we're looking for a z of 2.67. So we're going to go all the way down 2.67. So 0.9962. So we're going to have to subtract 1 from that. So here's the Word document. Once again, 1 minus 0.9962, which gives us a probability of 0.0038. Now this probability is lower than alpha equal to 0.01. So our decision is to reject the null. And now we have to calculate the effect size because there is an effect or a significant difference here. And we need to tell the people that are going to read our conclusion what the size of that difference actually is, okay? So we're going to calculate Cohen's d, and Cohen's d is just the sample mean minus the population mean divided by sigma. So it's 8 divided by 15, which gives us a Cohen's d of 0.5333. All right, so now we're ready for the conclusion. So our conclusion is to reject the null. And we state there is sufficient evidence to conclude that only children have significantly higher cholesterol levels, comma. Again, we need to provide our statistics to back up what we just said. So z, parentheses, n equal to 25 is equal to 2.67, comma, p is equal to 0.0038, comma, d is equal to 0.53, comma, medium effect. We let people know, yep, this is a medium effect, period. And now in English, only children have significantly higher cholesterol levels on average than the general population of children. So there we go. We've done a fail to reject and a reject the null, and they were both directional tests. All right, those last two tests, we were looking at directional tests, and we were looking on the right side of the distribution. So now we're going to look at directional tests, but on the left side of the distribution so that you can see what those look like as well. All right, so we'll start with number 3. 64, n equal to 64 smokers were questioned about the number of hours they sleep each day. We want to test the hypothesis that smokers need less sleep than the general public, which needs an average of mu equal to 7.7 hours of sleep, with a population standard deviation of sigma equal to 0.5. If the sample mean is m equal to 7.5, do smokers need less sleep than the general population? Conduct the hypothesis test using alpha equal to 0.05 and state your conclusion in terms of this problem. Make sure to use APA-style conclusions. All right, step 1. State our hypotheses, right? There we go. All right. So start with the alternative, right? So H1 in symbols is mu less than 7.7 hours. So we're now on the left side of the distribution. And our null, H0, is mu greater than or equal to 7.7 hours, which is everything else, right? The null hypothesis in words is smokers do not need less sleep on average than the general population. The research or alternative hypothesis is that smokers need less sleep on average than the general population. All right, so let's start the calculations. Here we go. Okay, so here are our statistics, or our numbers that we need, right? So always start with standard error first, again, to remove the fractions from the denominator of the z statistic. So sigma m, standard error, is equal to sigma divided by the square root of n. So 0.5 divided by the square root of 64, which is 0.5 divided by 8, which gives us 0.0625. Our z statistic is equal to sample mean minus population mean divided by standard error. So 7.5 minus 7.7 divided by 0.0625. which gives us a negative 0.2 divided by 0.0625, which gives us a z statistic of negative 3.2. Looking that up in the standard normal table, or the z table, our probability is 0.0007. The beauty of dealing with the left side of the distribution is that whatever is in the table is what we report, which is really cool. So this probability is lower than alpha equal 0.05. So we reject the null. And we need to calculate the effect size, because there is an effect and a difference, and we need to let people know how big of a difference are we talking about, right? So Cohen's d, again, is sample mean minus population mean divided by sigma. So 0.2 divided by 0.5 is equal to 0.4. And notice, no negative, right? Cohen's d, or effect size, is always a positive value. So we just kind of, we get rid of the negative sign. So it's really, think of it as the absolute value, okay? So here is our conclusion. Last step. Reject the null. There is sufficient evidence to conclude that smokers need significantly less sleep, comma, again, we need to provide our statistics to back up our claim that we just made. So z, n equal to 64 is equal to negative 3.2, comma, p is equal to 0.0007, comma, d is equal to 0.4, comma, it's a medium effect. And in English, smokers need less sleep on average than the general public. Whoops, typo there. All right. All right, one last problem, and now this is going to be a non-directional problem, okay? Or a non-directional hypothesis test. Suppose that we want to test the hypothesis that the climate has changed since industrialization. Suppose that the population mean temperature throughout history is mu equal to 50 degrees, with a standard deviation of sigma equal to 2 degrees. during the last 100 years, the mean temperature has been sample mean M equal to 54 degrees. Do we have sufficient evidence to conclude that the climate has changed since industrialization? Conduct the appropriate hypothesis test using alpha equal to 0.05 and state your conclusion in terms of this problem. Make sure to use APA-style conclusions. So step 1 is our hypotheses. So here we go. So again, I always start with the alternative, right? So it hasn't changed. We don't know what direction. Is it going to be a positive or a negative, right? Are we going to be on the left side of the distribution or the right side of the distribution? We don't know. So, or at least the researcher or, the question that's being asked doesn't tell us that. All it's saying is, has it changed, right? So our alternative, H1, is mu not equal to 50 degrees, right? And our null hypothesis, H0, is mu equal to 50 degrees, right? So the null hypothesis in words is the climate has not changed since industrialization. Our research or alternative hypothesis is the climate has changed since industrialization. Okay, so let's do the calculations for this. So here we go. So again, standard error. We've got our mu equal to 50, sigma equal to 2, n equal to 100. So 2 divided by square root of 100 is 2 divided by 10, which gives us a standard error of 0.2. Our z statistic, plug in the numbers, right? Sample mean minus mu divided by standard error. So it's 54 minus 50 divided by 0.2. Which is equal to 4 divided by 0.2, which is equal to a z statistic equal to 20, which, by the way, is not on the standard normal table. So what do? Let me show you real quick. All right, so here's the standard normal table, okay? So we're going to go all the way to the bottom, right? And where it says here, z greater than 3.50, the probability is greater than or equal to 0.9998. So we're looking for the probability to the right of this. So it's 1 minus 0.9998, which is a probability less than 0.0002. 1 minus 0.9998. So our probability is going to be less than 0.0002, okay? Because the last numbers that we could pull from this table without actually running a computer and it telling us what the actual probability is, this is all we can report, okay? So it's a really tiny probability. It's almost 0, right? So this probability is lower than alpha equal to 0.05. So our decision is to reject the null. And we have to calculate the effect size, right? Because there's an effect. And we have to say, how big of an effect are we talking about, right? So Cohen's d, sample mean minus mu divided by standard deviation, right? 54 minus 50 divided by 2, 4 divided by 2. Our Cohen's d is 2. Now remember, in our table, 0.8 was a large effect. So 2 is off the charts, right? So this is a pretty big effect, all right? So the conclusion is to reject the null. There is sufficient evidence to conclude that the climate has significantly changed since industrialization, comma, again, we have to provide the statistics to back up our claim. So z, n equal to 100 is equal to 20. P is, whoops, let me change that. I used a different table here. There we go. So P is less than 0.0002, comma, D is equal to 2, which is a very large effect. So temperatures have significantly increased since industrialization. And there we go. We've done 4 hypothesis tests, and hopefully this helps you. If you have any questions, let me know. Send me an email through Canvas inbox, or come to office hours, or virtual hours. All right, so just let me know if you have any questions.